Hey guys, welcome back. Today we are kicking off differentiation, and to nail it, we gotta start with limits. Now, limit itself is a concept that is very important in the subject of calculus. One amazing thing is that, in fact, the subject of calculus was evolved through the process of finding a limit. So, let's try to understand this concept, that is, limits of a function. Now, these are some notations. We will be having something like x approaches a. Now, for a given function, let's say f of x, if we say that x approaches a, this means that what is the behavior of f of x, which is this function, for the values of x around a. So, for instance, if we say s is approaching 4, then what we are saying is that what is the value of this function, which is its behavior as x approaches 4. So x could be something from 3.5, 3.8, 3.9, 3.999. So what is the value, the behavior of this function as x approaches the value 4? That is what is its limit. To better understand this, let us discuss the behavior of the function f of x equals 2x plus 3 as x approaches 4. Now, let us list the values that approaches 4. So, I'm going to start from 4.5, 4.2, 4.1, 4.01, 4.001. Remember, on the number line, this is positive infinity and this is negative infinity. And so if this is 0 and this is 1, this is 2, this is 3, and this is 4, all the way to infinity, then let's say this is 5. Yeah. So numbers could approach 4 from the left hand side or from the right hand side. And so in this example, we have taken from the right hand side. We could have picked 3.5, 3.7, 3.9, 3.99. That is from the left hand side of 4. If you are to plug in these values into this function, which is f of x, you are going to have 2 times 4.5 plus 3. And this is going to give us a value of 12. Then, if you are to plug in 4.2 into f of x, you are going to have 2 times 4.2 plus 3. And that is going to give us a value of 11.4. If you are to plug in 4.1, you are going to have 2 times 4.1 plus 3. And this is going to give us a value of 11.2. If you are to plug in 4.01, you are going to have 2 times 4.01 plus 3, and that is going to give us a value of 11.02. And finally, if you are to plug in 4.001, it is going to give us a value of 11.001. 2. Alright, so clearly we can see that as x approaches 4, we are obtaining a value of what? 11. We can see that when it was 4.5, it was 12. And as it gets closer to the value 4, 4.001 is very close to 4. We are obtaining a value which is 11. And so we can say that the limit as this function f of x approaches 4 is 11. And this is how we write it. Lim of the function, and the function is 2x plus 3, as x approaches 4 equals 11. Now, if the limit exists, then the left hand side limit will be the same as the right hand side limit. So if you are to pick numbers that are getting closer to 4 from the left hand side, that should also give us the value 11. So let's try to do that one also. So we were having f of x equals 2x plus 3, and you have to find the limit as x approaches 4. So on the number line, if this is 4, this is 3, and this is 5. So we first picked from the right hand side. Now we can pick from the left hand side. So you want to start with 3.4, 3.7, 3.9, 3.99, and finally 3.999. So pick your calculator, and then we are going to plug in these values into the function. So when we plugged in 3.4, we are going to have 9.8. When we plugged in 3.7, we are going to have 10.4. When we plugged in 3.9 into this function, we are going to have 10.8. We plugged in 3.99 into this function, we are going to have 10.98. And finally, when we plug in 3.999, we are going to have 10.998, which is 11 when we run it. Very, very close to 11. So you realize that the more we make x closer to 4, it tends to be closer to what? The value 11. And that is its limit.